Hello, welcome back to my series, The Impossibility of Man-Made Greenhouse Gas Global Warming. This episode is about Milankovic cycles. Hey, have you heard? It's getting warmer! And did you know it's been doing it for more than 40,000 years? That's right. The Earth has been getting warmer ever since the last ice age. Oh, well, actually, almost 3/4 of the way through the last ice age, actually. But the fact that the Earth has been getting warmer shouldn't be a surprise to anybody, because if the Earth hadn't been getting warmer since the last ice age wouldn't have ended. But of course, the question is, why did the last ice age end? What is the mechanism that causes the Earth to get warm? And that answer was found by him. That's Milankovic. And in 1902, he started working on the question of why did the Earth get cold and then warm. He finally figured it out and published his findings in 1920. And this is what he figured out. The Earth has a wobble. Astronomers believe that 65 million years ago, when that asteroid struck the Earth and wiped out the dinosaurs, it put a small little wobble in the Earth's orbit. That's been going bigger and bigger and bigger and bigger and bigger ever since. About 500,000 years ago, the Earth had its wobble get so large that the Earth experienced its first ice age. Well, since that time, the Earth's orbit has shrunk back and then expanded out 5 other times. We've had 5 ice ages and we've had 4 interglacial ages. And what we're in now is the 5th interglacial age. And this is what happens. When the dinosaurs were alive, the Earth's orbit was circular. And for the time before that, it was circular. The Earth was very near the sun. We got a lot of radiation. And the oceans were hundreds of feet higher than they are today. In fact, you probably know, if you grew up in the United States, that when the dinosaurs were alive, all of central United States was underwater. The sea stretched from the Gulf of Mexico in the south all the ways to Canada in the north. Now, as the Milankovic cycle grew, as it got longer and longer and longer, the Earth moved further and further from the sun. The last ice age occurred when the Earth was estimated to be 2.3 million miles further away from the sun than when it's at its nearest circular orbit. And that meant the Earth received about 24% less solar radiation than it did when it's at its circular orbit. It takes about 50,000 years for the Earth to move out to its furthest point, and 50,000 years for it to move back into its circular orbit. But there's one small problem. The wobble hasn't stopped growing. The wobble is getting bigger. And not only that, we've got the proof of it. Because ice cores taken from the northern and southern polar regions show that the ice ages are getting longer and they're getting colder, which proves that the Milankovic cycle is still growing, and it's not going to stop until the Earth drifts away from the sun in 4.5 billion years. Of course, as soon as we get out to the nearest point, our circular orbit, the Earth is going to start to wobble back out away from the Earth. And 50,000 years later, it'll wobble back in, and then it'll wobble back out, and then back in, getting a little further out every single time. Can we stop the Earth from warming up? No. There's nothing we can do to stop the Earth from warming up. We are going to get closer to the sun, and we're going to do it for thousands of years to come. The Earth is moving closer to the sun by 8.1 miles every year, which means we're going to be close to the sun next year. In fact, we're going to be close to the sun next month. And as we move closer to the sun, the Earth is going to get more and more solar radiation. So the question is, what's the Earth going to be like when we get to the circular orbit again? Well, since we've been at that circular orbit 4 times before, we know how the Earth is going to be. And how we're going to know is by simply looking at the fossils that were left behind. Here's Dr. Kevin Helmley to tell you a little about the corals that we have down in Florida and how they tell us what to expect when the Earth gets back to its circular orbit.
We're here in front of this impressive building built in the early 1900s because of the materials used to face its surface. These stones are constructed of fossilized coral reefs, and if you know what you're looking at, it can actually tell you quite a bit about Florida's past and maybe its future. I'm standing here about 5 or 6 feet above sea level and walking alongside this rock face, which is about 6 feet tall. The interesting thing about this rock face is it's actually composed of fossilized corals, and the fact that we're standing here today amongst these fossil corals tells us that in the past we would have been under 10 or 15 feet of water right now.
So there you have it. 130,000 years ago, the sea levels were 22 to 24 feet higher than they were today. And that's exactly what we're going to get when we get back to the circular orbit thousands of years from now. The sea level is going to rise, and it's going to continue to rise, which means Americans, in fact, all the people of the world have to decide, how are they going to deal with the rising seas? We can't stop them, so are we going to move further inland, or are we going to build huge seawalls to keep the water out? Well, that's a question we're going to have to answer. We have several thousand years before we get to the point of having sea levels 22 to 24 feet higher than they are today, so we've got some time. But this is going to happen. The Earth is going to get warmer. We can't stop it. We're moving closer to the sun, and sea levels are going to rise. The ice covering Greenland is going to be completely gone. And much of the sea ice in the north and polar regions are also going to be reduced. They won't disappear, but they will be significantly reduced. So we have to start making a decision now. Are we going to protect ourselves from rising seas? Or are we simply going to, like the polyps, move inland when the sea changes? All right? You have a good day. Bye-bye.